Hello and welcome to the masterclass presentation on the future of heating, which we believe is ground source heat pumps. Now a little bit about Kensa. Kensa have been market leader since 2012. We are a British manufacturer, so we're based in Truro in the heart of Cornwall. We're MCS certified in our own right, so this means that all our product meets the criteria to be able to claim the renewable heat incentive, and it also means that we're MCS installers in our own right. So as well as being manufacturers, what that actually means is that we can provide the certification required if you want to use your own plumber for the installation. We've been successful in gaining a wide variety of industry awards for our products and projects over the last few years. You can see a few of them illustrated on the slide there. So we're established in 1999, so we've got 20 years of industry leading experience. And all our heat pumps and the sort of range that we can supply are specifically designed for the UK market in mind. So Kensa as a company, we have strong links to the Department of Energy and Climate Change, and we have significantly contributed to government policy. We seek to secure helpful policy outcomes to underpin further growth in the ground source heat pump market. Essentially, we believe that we can deliver the lowest cost and lowest carbon heat to the householder, and we also believe our technology is central to the lowest and decarbonisation pathway. So, as I'm sure you're all aware, we have certain emission targets that we need to meet. So, we're looking to be net zero by 2050, and we believe ground source heat pumps are going to be the way forward to help us get to our targets. Now, preparing for a future without gas. So really, certainly in new build housing estates, we're seeing it more and more that renewables have to be a part of building regs moving forward. So an alternative fossil fuel may not be an option. So now really is, it's a case of the carrot and the stick sort of philosophy really. So at the moment it's very much the carrot. There's lots of incentives in place to consider the uptake of renewables. But moving forward, in the fullness of time, there may not be that funding available. So it's going to be more of a stick that, you're going to have to do something renewable as opposed to using a fossil fuel. So now's a really good time to look to do this. Now further to this, we've also got sort of smart controls and time of use tariffs, which can be sort of integrated with our heat pumps. So the smart controls can be used with Kensa software that are built into the heat pumps. And basically what it does, it helps you time of use tariff. So what it does is it helps occupants able to sort of make best use of dynamic tariffs really by the smart controls will sort of predict and learn how the user wants to use the heat pump. So companies like Octopus Energy, so they've launched this time of use tariff which offer lower prices for select periods of time. So what that does, it helps to reduce peak electricity demand at times of high system load. So it basically has a positive effect on the grid. So it stops the sort of huge peaks that you see. So coupled with, an efficient heat pump, smart controls, time of use tariffs, it really can get you the best system, both in terms of the environment and returns through your investment as well on the RHI. So why choose a Kensa heat pump? So there's no need for any additional heating, so you don't need to have a backup boiler. We'll size it to meet 100% of your heating and hot water load. Heat pumps are very efficient, so using minimal electricity to generate high temperature heating out of low grade energy. So this means that potentially you can reduce your heating bills for up to 50% compared to oil and LPG. Off the back of that, you also have the renewable heat incentive, so it's the most generous tax-free income that the government have put in place for the uptake of renewable technologies. It's got a low lifetime ownership cost, so there's very little ongoing maintenance costs associated with the heat pump. It's safe and non-combustion, so that means basically there's no gases and there's nothing like that comes from the heat pump itself, so it's safe to go inside the property. It's also got a high COP, so what that means is that the seasonal coefficient of performance is high, so for every kilowatt of electric you put in, you potentially get 4 kilowatts of heat out. So depending on your setup internally, ideally, underfloor heating, oversized radiators, to accommodate as low flow temperature as possible to maximise your RHI payments. The heat pumps themselves, they've got a 20 to 25 year lifespan. The ground aerator will clear about 100 years. So, you know, they're really reliable and robust. So unlike sort of most boilers that would need replacing every 5 to 10 years, these are very much sort of, you know, really the lifespan for sort of 20 to 25 years. Unlike air source heat pumps, no planning permission is required. So there's nothing to see. The ground arrays are buried and the heat pumps go inside a building or in a garage or something like that. So there's no need for planning permission. Okay, so your funding options. So as we sort of touched upon just now, we have the renewable heat incentive. So for self-build projects, we've got the domestic renewable heat incentive. So it's basically been put in there for the adoption, the take-up of renewable technology in the UK to reduce carbon emissions, so we hit our UK targets. So the RHI is calculated to cover the majority of the equipment costs of your ground source heat pump, as well as some of the installation costs as well. So as we sort of mentioned earlier, the highest tariff is for ground source heat pumps to cover that sort of higher capital and installation fee. The domestic renewable heat incentive is a 7-year payback scheme, and it's payable based on the deemed heating and hot water usage on the property energy performance certificate. Now that's also coupled with the system efficiency. You get the most efficiency by ensuring that the building is well insulated. So we always encourage to insulate as well as you can, really, you know, purely from an environmental perspective, but also to keep your running costs low. So you're not, you know, putting a lot of electric into the heat pump to make it work very hard. You know, you want that heat pump just to sort of tick over to heat really at a sort of minimum output to give you, you know, equally the most amount of comfortable heat. So you want to keep that system as efficient as possible to get the most from your RHI payments. The non-domestic renewable heat incentive, so that's actually due to end next March, so that's sort of kind of coming to a close now. That is an index-linked 20-year payment, again based on the deemed heating and hot water usage on multiple domestic properties on the EPC, or a metered basis, depending on what the application is. Now, it might also be worth mentioning back to the domestic RHI, this is actually due to end in March 2022. So this is a really good point now to sort of start looking at this, because beyond that point, it's probably just going to be a one-off £4,000 upfront grant. So now is a really good time to start, you know, thinking about doing this, whilst the tariff also is at the highest it's ever been. Now, to run through run next to the renewable heat incentive, we've also got the Green Homes Grant. So this is another time-sensitive incentive. It will cover 2/3 of the cost of home improvements on existing homes. It's to help with upfront costs. So often a barrier to entry for us is the high upfront cost of installation and capital costs, but this will help just, you know, help reduce that really. So once obviously you get the voucher up front, that is then deducted off your RHI payments. But it will help anyway in the first instance just to cover some of those higher upfront costs. This scheme is open now, and then that's actually due to end next March. So you've got a sort of small window to get on the Green Homes Grant. So an example of this, so we've got plenty of case studies and costed examples on our website. You can see from this example the benefits of installing a heat pump compared to a traditional boiler are clear to see. So with low running costs, minimal maintenance, and a long lifetime of a ground source heat pump, coupled with the government's domestic renewable heat incentive, make a strong financial case for self-builders looking to offset project costs and make long-term savings. So if you have a project that you'd like to know a little bit more about in terms of what it's likely to cost you to run the heat pump, but also the renewable heat incentive returns, just drop us a line, send us your project details, and we'll be happy to give you an accurate idea of what that's likely to cost you and your returns as well. And we'll always do our best to sort of explore every avenue to ensure you get the best return on your investment. So a little bit about how a ground source heat pump works. So effectively, the ground sits at around about anywhere between sort of 6 and 10 degrees most of the year round. You install ground arrays, so effectively that's pipe that's put into the ground. You circulate antifreeze within that pipe. That pipe then transfers the ground energy to a refrigerant in the heat pump. And in the part of the heat pump, the sort of refrigerant and the process within the heat pump itself, there is an increase in pressure, which raises the temperature of the refrigerant. And then this heat is then transferred to a room via radiators and underfloor heating. So it's sort of useful energy really. And then once that refrigerant has done its part by providing high temperature heating, it's then put through an expansion vessel to then cool. And then this process just carries on going. So it's a continuous cycle. It never really goes wrong and it never runs out. So it's a good, reliable, robust system. Okay, so where do we get this energy? So there's a variety of options available. So we have the slinky ground array. So if you have a paddock or a field nearby that you'd like to use, we can advise how many slinkies you're likely to need. This can also be straight pipe loops as well. So the principle is still the same. You bury a pipe work in the ground about 4 foot deep, and you circulate antifreeze within the pipes, and you get really around about sort of 5 kilowatt approximately per slinky trench. And we can size that for you and advise what you'll need, according to ground conditions and the heat demand of your house. If you don't have enough space for slinkies, we've got a borehole solution, so you can drill down vertically. So if, for example, you've got a small garden, you can't put a horizontal ground array in, you can drill down anywhere between 50 and 150 meters to absorb the energy from the surrounding soil. You typically will get, again, probably around about 5 kilowatts per 100 meters, depending on ground conductivity. This option tends to be a fraction more efficient, but it is a bit more expensive. So just something to sort of bear in mind when you're weighing up both options. You've also got the water source option. So if you have a lake, a stream, a river nearby, you can potentially utilize this. So you have the option of open loop. So you're physically extracting the water from this water course and passing it through a heat exchanger to take the energy from it. Or you have a closed loop system. So this is pond mats. And pond mats, similar in a way to slinkies, so it's coiled up pipe onto a frame, and then that's absorbing the energy from the surrounding water. So that does require a little bit more maintenance though, so not so much of a fit and forget system as the others are. So the careful consideration needs to be given to that. But we'll look at all possibilities with you, and we can discuss each project on its merits, and we'll look at each of the options to get the best return on your investment and best system for you. So Kensa's award-winning product range. So we have 28 variants across all ranges. So ranging from a 3 kilowatt shoebox. So these are designed to go in flats, small passive houses, and also boats as well. We have our Evo series, which is designed for sort of generally the domestic market. So for new builds and large retrofit properties. Twin series for our larger properties that require a slightly higher heat demand, all the way up to our plant room heat pumps as well. So for we've seen applications in offices, schools, golf clubs. So in response to market demand, we have developed our latest range of heat pumps, which has been well thought out, and it's developed based on 20 years of customer and installer feedback through innovation and research and development. So we've come up with our Evo series, which has been an extremely popular heat pump. The benefits of which, so it's extremely efficient. So the A++ will absolutely maximize your RHI income. So with the highly efficient system, so if you have your heat emitters sized to accommodate a low flow temperature, you've well insulated your property, and as well going on a time of use tariff, these will absolutely maximize your system efficiency. So you'll get the best return on investment through your RHI and also experience the lowest sort of running cost possible. It will deliver high temperature hot water, so typically about 60-degree hot water, so there's no need for an immersion backup. It's got a smart system manager as well in it, so that'll also optimize performance. So that means it's got a built-in sort of software specifically designed for this unit. So it also has built-in diagnostics, so it preempts any system irregularity, performing a system maintenance check, and it all helps keep ongoing maintenance to a minimum. They're also very, very quiet. So they've been built with sound in mind. So they've got industry leading sort of sound level. So they're very, very quiet. They're then designed to go indoors, so inside the property. So they don't have to be kept in a garage or an external enclosure. Further to this as well, the Kensa have always sort of liked to keep installation and the heat pumps themselves easy to install. So with that in mind, it's been developed with simplicity and ease of commission, really. So then it can be commissioned over the phone with one of our Kensa engineers. And the connection location on the heat pump itself, it makes it quick and easy to install, and with being flexible on site, so it doesn't have to go in one particular area. So it's very much been it's been designed with ease of installation and use in mind. Okay, so what's next? So if you have a project that you'd like us to run through with you, if you'd like to have an idea on the return on the RHI, your running costs, what size heat pump you're likely to need, how much ground you need, please give us a call. We're happy to run through any questions you may have. Drop us an email, send in your project plans, and we can have a look at each individual project and work out the best system for you. And we're also here all weekend, so come and see us on our stand. We're Trade Village stand number 68. And we'll be happy to discuss your projects with you. Thanks very much.